What's up, guys? Van Zeven here from Designs by the Sphere, and we got some good news and some bad news today. So you might not like it, you might like it, I don't know. So recently, last week I started up a Minecraft series as well, and that series, my computer can handle rendering and recording it all. It's very, very intensive on my system, and I just cannot be bothered to wait around for a few hours, well, more than a few hours, depending on what it is. But I can't be bothered to wait around for a few hours waiting for something to render. So I'm just going to pause that series for now, put it on pause until I get a better system, which should be soon enough. But so that's that. And we're going to replace it today. We're going to start off a new series that I've been heavily interested in as of recently, which is going to be a Java 2D game development series. This is going to focus on the kind of 2.5D. I'll probably put some images up right now of what the style is. It's kind of the 2.5D that you see in games like the old Harvest Moon and Pokemon and StarCraft kind of has it as well, stuff like that. So it is technically 2D because you can only go for like up and down, which is technically forward and backwards and left and right. You can't really go up and jump and stuff like that. Although we could simulate it, it isn't technically 3D. So that's the actual style that we're going to be teaching you guys how to do. Right off the bat, you should know some basic Java behind this series. Go check out some of my beginner tutorials and check out some of the new Boston's tutorials because he has good tutorials as well on basic Java development. If you know some stuff about how JFrames and canvases work and stuff like that, that's good, but I'm going to be teaching you a little bit about that today. I'm not going to go into too much detail. Well, I will with some things, but some things I might not. So if you need any clarification on things, just post it in the comments. And yeah, today we're going to start out by creating the main game class that's going to be used for just displaying the game on screen and doing not the actual screen class, but the game, just the core of the game. So let's start out today. We're going to start out by creating a new project, and new Java project. And I don't know why I'm in the navigator, but that's okay. And we're going to call this Java 2D game. Alright, just for now. And while this is creating, I will just wait for it. There we go. Let's go back to the Package Explorer. So we're going to extend this down. So you see that we have our source folder. And we're also going to need a res folder just for additional resources that we have in the game, like images and sprite maps and stuff. So we're just going to create a res folder. And we will also need to add it to the build path because this will allow for the game to actually load these res folders into the when you export your game, it'll bring that res folder into the game as well. It's saying that I need it instead of just leaving it out. So you just do that. You go to sorry, went kind of fast there. You go to 2D game here, right click on it, go to properties, then go down to build path over here, go to libraries, then go to add class folder, and click on res, hit OK. And then it'll pop up there, and then we hit OK, and then you should see a little symbol pop up here, run in the background. A little symbol pop up there, and that says that it's in the build path now. So next what we're going to do is we're going to create our package. So I'm just going to typically keep it all lowercase. You guys should know this kind of stuff by now. And we're just going to make the package name 2D game. We'll just call it game. Okay. And there's our main package. So we're going to create our main game class as well. Like that. Okay. So this is the class that's going to be run. As with other tutorials that I've done, we will have the private static void main in this class, so that's the first thing that'll get run by the JVM when it searches for this package. But first, what we need to do is the game class is just an object right now. We need to extend canvas, and what canvas is canvas is kind of a blank canvas. It's a blank working space that we can work on, and we can then override with JFrames and stuff like that. We're also going to need to implement runnable. Okay, so implements runnable. Oops. Okay, and then we're just going to hit Command-Shift-O or Control-Shift-O on Windows to import those packages. You may see me do that quite a bit, so that's the shortcut to do that. Then we're just going to hover over here. We're going to add unimplemented methods, and it's going to add this run method here. We don't want this because we already know that it's going to be overridden. We are also going to add the default serialized ID, which is right here. You don't really need to worry about what that is or what it does because it's not really relevant. at this point in time. Next, some things that we're going to need. We are going to need a width of the game. So we're going to create the width. So it's going to be a public static final. I will have a tutorial up on what these modifiers mean in my basic Java development tutorials. So check that out for what they actually mean. Essentially, this is just saying that this is a variable that's going to stay at this number. It's never going to change. It's going to be an int, and typically, by convention, they are all uppercase. And we're just going to set it to 160, because this game is only going to be an 8x8 game. We're not, like, the sprites are only going to be 8x8 for the basic ones. So we don't want it too big. 160 is really small, however, so we're going to, hold on. First, we're going to create the height as well. And the height, we're going to set it to the width divided by 12 by 9. So that's the resolution of it at it's a 12 by 9. So it's just kind of like a box. Then we're going to need a scale. And the scale here is going to allow us to scale up the game, because if we left it at 160 by 120, it would be the tiniest little box on your screen. So the scale factor is going to allow us to make that tiny little box a lot bigger. And this is also going to be an int. We're going to call it scale, and we're just going to set it to 3 for now. We might increase or decrease these numbers at a later date. Next, we're going to need a game. So we private, public static final string and name, and we're just going to call this game for now, just because I can't really be bothered to think of any better names. We're also going to need a JFrame, okay? And this is just, actually we only need this to be private. We're including the JFrame inside this, we're going to call it frame. We're including the JFrame inside this package because we may want to change some of the variables of it at a later date, and we don't want to just set them once and leave it, so we're just going to put it inside here. The JFrame is essentially just the JFrame object of the thing. It's kind of like a canvas. It's just a writable area that we can put stuff on. And it's part of a window. It's used for application development heavily, like this is a JFrame right here, and a bunch of different stuff. So it's used for application development, but we're going to put stuff inside that JFrame. Next, we're going to need the actual image of the JFrame, because essentially what we're going to have is we're going to have this JFrame, and on that JFrame, actually we'll leave this image out for now. I'll get to that in a minute. We'll leave that out for now, and we will just go straight into the actual, let's go into the running. So we need to set up the JFrame first. So we're going to make a class, a constructor here, to set up this JFrame. So we're going to say set minimum size to set the minimum size of the canvas, okay? And we're going to set this size to width. It needs a dimension. So it takes a dimension, which is just a width and height. So it's going to be new dimension, and width times scale, and height times scale. Okay, and we're going to import that with Control-Shift-O. We're going to copy this down too, because there are two other ones that we're going to need for sizing. So there's going to be maximum and preferred. There you go. And what these allow you to do is these three things in conjunction will set the size of your frame, and it will allow the minimum size to be the minimum size. It's just going to keep your frame at one size. We'll also make it so that you can't resize them later on, but we'll do that in a minute. Next, we're going to need to actually create this JFrame, because right now it's just pointing to null. So we're going to say frame equals new JFrame, and we're going to say name to set it to the name here. Next, we're going to set the default close operation. Okay, so what this is it's essentially what the system does when this JFrame is closed. So set default close operation, and it takes an int, and this int is there's a bunch of different public static final variables in here, and these are all these. As you can see, they're all uppercase, public static final int. And we're going to exit on close. And essentially what this is doing is it's saying when the game's done running, when someone closes the game, just exit it and get rid of it, and don't worry about, just get rid of it completely. Next, we're going to set the layout of it, and this is just going to help. This is going to keep some things in check so that the frame is actually centered and it's nicely positioned inside the window. So instead of having, because sometimes some people forget to do some things with it, like they might set the frame to the minimum size, and that's going to screw up with the title bar, because this is, I think, 22 pixels, something like that. It allots for the title, and that might just screw up the sizing of your frame. So we're just going to be sure, and we're going to set it to a new border layout, which is It's something that you would learn. You don't need to know what it is. It's just a way of laying out a JFrame. So there's new border layout. We're Control-Shifting O. Oops, I spelled layout wrong. There's that. Next, we're going to we're going to add the frame, or we're going to add the game to the frame. So we're going to add this canvas to the JFrame, to the whole thing. So we're going to say frame dot add like that, and we're going to say this, and we're also going to put it in the center. So we're going to say border layout dot center, because we want this canvas here to be centered inside this JFrame. Okay. Oops. Next, we're going to pack it. So frame.pack. What this does is this essentially sets the frame so the sizes are above or they are at the preferred size. So it keeps everything sized correctly, is what that does. We're also going to set it so it's not resizable. So we're going to set it to false here. Okay. Additionally, we want the location relative to, and we're just going to set it to null because we don't want it to be relative to any sort of location here. We just want it to be centered. And then finally, we're going to set it to visible. Set visible, true. Okay, so there's the constructor of the game. Nothing would happen yet because we still don't have our main method here. So let's just create that main method. So public static void main, oops, string, which is an array, args. And what we're going to do here is we're going to create a new game. New game. Oops. Dot start. We don't have this method yet. We're going to create this method right now. So create method start game. Where did that go? We want it to be above this. So we'll put it up here. And this is going to be a synchronized it's going to be a synchronized function. Oops. Synchronized. How did I spell that wrong? Where's the H? CH. Oops. H. There. So it's a synchronized function. This is going to be useful for when we create our applet, so we can just call this function from our applet, because this game, actually this should be public. This will also be in, well, you can put it in a browser and you can have it as a downloadable. So that's what we're going to do here. And with the start, we're also going to need a stop. Stop. Okay, so those are the same. And in the start, we will create the thread. So this game is going to be run in a new thread. You don't really need to know about threading and all that. The thread is going to be an instance of runnable. That's why it needs to implement runnable. And whenever this thread is started, it's going to run the run function. And then in that run function, we're going to have our main game loop. So this is just creating a new thread so that we don't take away from the system's main thread. We can just have a kind of new side thread. It's good for multitasking, which we might get into later on. I don't know. So that's that. We're also going to need a running variable. Public boolean running equals false. And when we start the game, we're going to set running equals to true. And we're going to set that above the thread because we want running to be true first. And here we're going to say running is equal to false. Okay. And in this run function, we're going to say while running. Okay. And right now, we're just going to print out a message. Okay. We're going to say hello world. Just because. Oops. Okay. So now we have the main game thread, and we have, yeah. So we should just start running this. We'll run it in debug mode, just so that pops up here, and we can change things on the fly. So you'll see that we have this game frame here. This is a JFrame with the canvas inside it, and we just got a bunch of hello world spitting out. So we're just going to cancel that. You see when it's closed, it'll dispose itself. So there's that. We're just going to test things as we go along just to make sure that things work. It's not like we're going to be keeping some of them. Most of the stuff we will keep, but we might just remove it just because it was just for testing purposes. So next thing, we are going to, what are we going to do? In the run method, okay, here we go. We're going to need a tick and a render. So a tick function, public void tick, and public void render. Okay, so this tick function is going to update the game. It's going to update all the internal variables. It's just going to update the logic of the game, and the render function is going to print out what this logic has said to print out. So that's essentially what those two are going to do. And in the run method, we're going to just call tick, and we're going to call, render. So now every time we're running, we're just going to update the tick and we're going to update the render. But this is going to be very bad, because on some systems, this while loop will run a lot faster than other systems. And that means that their game's going to be updating faster, so that people will be moving faster, mobs will run faster, etc., which is something we don't want. We want to limit this to approximately 60 updates a second. So that's what we're going to do now, and we're just going to get right into it. So first we need a last time variable. Long last time. Time. And this is, we want it to be as accurate as possible, so we're going to use nanotime. Okay? Now this just gets the current time in nanoseconds from the epoch, which was 1970 something, like 1970 the year, and till now. So that's the current time there. So now we're going to create a nanoseconds per tick variable. Double ns per tick for nanoseconds per tick. And this is going to be a billion, because that's how many a nanosecond is. 1, 2, 3, 4, 5, 6, 7, 8, 9. And it's a double, so we're going to put a D. That just signifies that we're using a double. We could also do a .0, but this is a lot simpler. And then we're going to divide it by 60. 60 double. And what this essentially is this is going to come out with how many nanoseconds are in these 60 updates that we're going to do. That's essentially what that number is. Next, we're going to have a variable for the frames, so the current FPS. So we're going to have int frames equals 0. We're going to also have an int ticks equals 0 for how many updates, and we'll put the updates above the ticks. We're also going to need a last timer, so a time to reset the data. So we don't want to just keep updating these ticks and these frames. We only want to do 1 a second, because we want to find FPS, which is frames per second, or UPS, which is updates per second, which is ticks. So we want to have when that second has occurred. So we're going to call it last timer equals, and this just has to be in milliseconds. We don't need anything more than that. So current time millis. Now we need the delta variable. So the delta variable is a double. There are many different names you could call this, like unprocessed. This is just how many unprocessed nanoseconds have gone by since like a delta. So it's going to be 60 when it hits that 60 variable. When it hits this number, this 60 here, we're just going to reset it every time. So what we're going to do now is we're going to say long now, because this is going to be the current time to check against last time, equals system.nanotime. Okay. Then we're going to add to the delta. So we're going to add some time to the delta, so plus equals, and it's going to be now minus last time. So the current time minus the last time, that's going to give us a number, and then divided by ns per tick. Okay? And then we're going to set the last time to now, just so that we are updating this every time instead of just keeping this static. And that's that. So now we're going to put a while loop here. So while delta is greater than or equal to 1. Okay, and then we're going to say ticks plus plus. We're going to tick. We're going to minus 1 from delta, and we are going to. That's about it. So now what's going to happen is this game. Last timer. There we go. So this is going to run, and we're going to go through this running loop, and this is going to run consecutively every time in here. It's going to run until it hits this 60, and then it's going to continue, and it's going to minus that 1. Okay, simple stuff. Next, we're going to add to frames down here, and then we're going to create that second variable to reset frames and ticks, because if we run this right now and we just print out dot print line, and we print out frames, and ticks, what's going to happen here is you're just going to see this number keep getting bigger and bigger and bigger. So it's going to go whoop, 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 whoop. So as you'll see, this number is exponentially larger, and this number is how many updates we've done. So this is exponentially higher than this one. It's ridiculously high. So this is how many, wait, no, this was the frame. So this is how many times we rendered the frame, and this was how many times we rendered the updates. So the updates are being limited. Sorry about that. The updates are being limited to 156. So that is good. So that number is not good because we're not resetting these two variables. They just keep getting bigger. So each second we need to reset them back to what they should be. So that's what this last timer is for. So we're going to do here, we're going to do an if system.current time milliseconds minus last timer. What this is going to print out is it's going to print out a long milliseconds. So we want to put it into seconds, 1 second specifically. So 1 second is 1,000 milliseconds. So that's all we need there. So we're going to say what if the current time minus the last time that we updated is greater than 1,000, update. Actually, greater than or equal to, we could do. Yeah. Now we're going to set last timer. We're going to just add 1,000 to it because we want to say we want to update in another second. We are going to print out the ticks. I should have just left that method. Print line frames plus ticks. Okay, and then we're just going to reset them. So frames equals 0, and oh my god, my fingers aren't working. Ticks equals 0. So now what you'll see is these variables will get reset once a second. So you'll see the updates are approximately 60 because we're updating 60 a second, and the frames is just exponentially higher because we're not putting any sort of variable limiting on that. We're not really rendering anything; it's just going. So that's why that's so huge. So what we're going to do now is we're going to limit the frames that we can actually render because we don't want to render this many. Like, yes, it's good to see for performance issues how many we're doing, and we can have that later on. But we don't want to see that right now because we don't want to overload our system while it's debugging this stuff. So what we're going to do here is we're going to create a running variable, and we will create that here. Boolean should render. And we'll just set it to false for now. And every time we do this update, we're going to say should render equals to true. So we're going to say we should render every time this thing's done. So these two numbers will be together. And then if should render, put that in there. And yeah, that should do it. So we're going to run this, and it should stay around 60. 59, 60. You see now these two numbers are the same. So this is how many frames we have, and this is how many updates we've done. And I should actually reverse those because that's kind of confusing. So 59 ticks, 59 frames, 60, 60, 60. It'll hover around 60, which is great. But what we're going to do is we just want this to always be true. We're not going to leave that. We just want it, for now, we're going to leave it to true, and we're going to put we're going to put a sleep in here just so the system doesn't get overloaded, because if we run this again with it true, it's going to do what it was doing before, where it's just insanely, yeah, look at that. That is ridiculous. So right here we're going to do a thread.sleep, okay, 2, and yep, let's run with try catch. There's that. Now I should run it, and there should be a little delay, and that's good. So you'll see it's only 440 now as opposed to 5, whatever the hell that number was. So that's good. So now we have a pause, and it's not overloading the system with that. It's perfect. So now we're going to put some content in here. In ticks, every time there's a tick, we want to update a variable here. So we're going to have a variable for ticks called tick count. We're just going to set it to 0 there. And every time this, we're going to do tick count plus plus. Just for how many ticks there are, just so we can see. In the render method, now here comes the important stuff. So we got everything else pretty much done. What we need now is we need an image, because we have that frame there, as you can see, if I run this again. We have the frame, but the frame does not have anything in it. It just has this canvas inside it, which is what we are. So what we need inside that is we need to overlay that canvas with an image. And so what we're going to do here is we're going to say, actually let's make it private. Private buffered image. Okay, and we're going to call it image, and it's going to be equal to new buffered image, the width of the image, so the width, the height, and then we're just going to set it to the type. Oops. ERED image dot type underscore int underscore RGB. Okay, so we don't need anything more than that. It's just a basic RGB in this. There is also an alpha that we could put in, but we don't need that. We're also going to need a pixels variable, and this pixels variable is going to represent how many pixels are inside this image. It's going to be an updatable, so we can update the pixels field with certain values for what the pixels are inside this image. Sorry, I'm kind of hiccuping right now. So that's going to be an array of ints. We're going to call it pixels, and we're going to set it equal to data buffer int. Is that a capital? Yes, it is. Buffer int, and it's going to say image.getRaster .get data buffer, and then go outside these brackets and go get data. Okay, and we're just going to import all that stuff with Command Shift O, Control Shift O, whatever you're using. So now we have a pixels variable, and we can update this pixels variable with whatever we want, and it will update that image. So what we need to do now is display that image when we render. So we need a buffer strategy. So buffer strategy TGY BS equals get buffer strategy. What this buffer strategy is it's an object to organize the data on this canvas. So it allows us to organize what we're putting on here. Now if it's null, so if that buffer strategy is null, we're going to create one. So create buffer strategy, and this takes an int, and that's how many times, like what kind of buffering we're doing. And we're going to want to do triple buffering here, so we're going to put a 3. You could also do double buffering, but what essentially that means is triple buffering, the higher numbers you go here, the better it will be at reducing tearing in your image and reducing cross-image pixelation. Because sometimes with an image there's, when you update a JFrame or you update an image, there's 2 different ways that you could do it. You could clear the whole image and just write to it again, or you could like find out which pixels have been changed and which haven't, and then update those pixels. But for this, it just clears it and runs it. So that's gap between the clearing. That would be called tearing or an image distortion kind of. So we want to make sure that that doesn't happen, because if we have like an image going to like a blank canvas every frame, then that's not good. We don't want to see that. So we're just going to set it to 3 because this is going to provide triple buffering, which is better at reducing tearing and stuff for the most part. So yeah, next we're going to get the graphics object. Graphics G equals bs.getDrawGraphics. Import that. Okay, so now we have our graphics object. What we're going to do right now, we don't need to do this step, but we're going to set the color. We're going to set it to color.black. Okay, we're going to remove this later as well. We're going to import that as well. Then we're going to do a fill rectangle, 0, 0, get width, and get height. Okay, and now we're going to need to dispose the graphics, because this will free up the memory in the graphics and free up any resources that the graphics object is using, because we're not using it anymore. And we're going to do bs.show to show the contents of the buffer. Okay, so there's the render, and if we run this now, you will see that we have a black screen now, a lovely black screen running at approximately 60 frames a second. This is going to change because we're not limiting it anymore to 60. So this will go up and down. My system's a little overloaded at the moment. Needs a restart. But yeah, that's that. Next, what we're going to do is we're going to draw the image that we created up here. So this image here, we're going to draw that. So we're just going to do g.drawImage, okay? And then it's going to say image here at 0, 0, the width, yep, and the height. And this can all just be null, because we don't need this. So there's that. Now it's going to put the whatever the contents of that image is, it's going to put it on the screen. So we're going to run this again. And you see we have our black screen again. We're still running out of... This frame rate is really bad right now, but that's just, again, because I'm recording and stuff. So we'll also remove this because we don't need it anymore. Actually, we'll just leave it for now because the image doesn't have anything in it. What we're going to do now is we're going to put just some random images on the screen. So we're just going to create a normal for loop, int I equals 0. I is less than pixels.length, I++. This is just to verify that the pixels does actually work and that we can update the pixels and it'll update the frame as well. What we're going to do here is we're just going to say pixels at I is equal to I plus tick count. Because we don't feel like we could set it to a specific color or whatever we want, but we're just going to set it to just a random number that'll update itself. So that you'll see a moving screen here. There we go. It's perfect. See a moving sideways screen. And these all variables, these are all being set here, and they're all going back into the image here, and then being displayed on the screen through this line. So we could remove this now, and if I remove this, it should update this as well. So if I go with something like this, like g.draw rectangle 0, 0, get width, get height, oops, t, and then if I save it, it should just be drawing a black screen, which it's not. Set color, oops, color dot black. Save it. Why is that not updating? Will this update it? Yeah, that definitely updated it. So something with the render function. Not sure about that. We'll figure that out in the next episode, and I'll tell you about that, why it's doing that in the next episode, because I'm not really sure why that's working like that. But, yeah. So now you have your basic image. We'll actually take this back out because I don't want to do that. I just want to draw the screen. You have your basic image, you have your basic game. This is where the game's going to be. And you'll notice that it's not resizable or any of that. It's all right here. Frame rate is horrible at the moment, but also remember that we are sleeping. So if I take this sleep out, should be running quite higher. Yeah, it did. I think. But anyways, that's enough of that. So this has been the first tutorial. What I'm going to do is I'm going to record a bulk of these. So I'm going to record I'm just going to record like 10 of these in consecutive order, and then I'm just upload them all one a day apart, because I don't like having these tutorial videos so far apart, because then you get disinterested in what you were doing and you can't really focus. So these are going to be consecutive order, and I'm just going to upload, and we'll go once a day. So this has been the first tutorial. So thank you, and I hope you guys learned a bit from this. I'll post the source code on a link in the description, so click that below. I'm also going to clean up the imports up there because it was spitting out a warning. So I hope you guys have a good day, and yeah, see you later.